Okay, so we're going to do what are called graph transformations, and you'll have a library of functions handout tomorrow that's got some basic functions on them. One example, or one of the functions that's going to be on that library of functions is f of x equals x squared. And so we're familiar with this. It's a parabola. Its domain is minus infinity to infinity, and its range is 0 to infinity. And now what we're going to look at is how each one of these graphs, each one of these functions changes the original graph. So how does this graph change compared to this one? How does this change compared to that one? And so on. There it is. All right, so here is the regular f of x equals x squared. Okay. This was the first graph. G of x equals x squared plus 3. And so how does this red graph change, or how is the red graph different from the black graph? And so they both have a vertex. This one is at 0, 0, and this one is at 0, 3. And so what happens is each point on the black parabola is moved up 3 points on the red parabola. So the vertex is up 1, 2, 3. This point here at 1, 1 is 1, 2, 3. And this point 1, 2, 3, it goes off the screen so we can't see it. But each point on the original black graph is moved up 3 points to get the red graph. So this x squared plus 3, the plus 3 moves the graph up 3. So up 3. Now let's look at what happens when we put x minus 3 in the parentheses. So the blue graph's the result. And we see that it moves over 1, 2, 3. So x minus 3 in parentheses moves the graph 3 units to the right. Every point's moved 3 units to the right. If I look here, 1, 2, 3, 1, 2, 3. This point, 1, 2, 3. 1, 2, 3. So each point is moved over 3. So the minus x minus 3 squared moves x squared 3 to the right. We look at the orange graph here. This is x plus 3 squared, and it moves it 3 to the left. Okay. Let's look at what happens when we take x squared and multiply it by a negative. It flips it over the x-axis. Okay, every point is flipped. So this point comes down here. This point comes down here, here to here, here to here. Okay, so when you put a minus out front, it flips it over the x-axis. Here we have x squared, and we've multiplied it by 3. So 0, 0 is still there. This point is moved up 3. And this point, since it's at 4, we take 4 times 3, it's going to go up to 12. So each one of these points, it's stretched by a factor of 3. This is 1/3 x squared, and it is stretched out by a factor of 3. So this point comes to 1/3. This one is down at, so this is 4/4. So as opposed to stretching it, it kind of compresses it and makes it fatter. Okay, so let's go back to our here, and let's write down what happened to each graph. So this one moved up 3. This one was right 3. left 3, flip over x-axis. This was stretched by 3. And this one was compressed by 1/3, or we can call it stretched by 1/3. And I think we call this a vertical stretch. So let me go put that in. Vertical stretch by 3, and another vertical stretch by 3. Or by 1/3. Okay, so what happens to each one of these? The domain for all of these is going to stay the same. But when the things change on the y-axis, when we move up or down or flip over the y-axis, what happens is our range is going to change. So if my original range, the range of x squared, is from 0 to infinity, when I add 3 to every point, my new range is going to be 3 to infinity. Here I'm moving horizontally, so my range stays the same. Another horizontal, so my range stays the same. Here I flip over the x-axis, so if I have 0 to infinity and flip it over the x-axis, I get minus infinity to 0. And then these, they're vertical stretches, but I'm pinned at, I still go from 0 to infinity. So this does not change my range. All right, and so that is what I wanted to show for here. So in the next video, we continue to talk about this in a more general sense.